Hello, this is Yashvin. In this video, I'll be solving paper 4 variant 2, October-November 2018, 0620 chemistry. Starting with question number 1. Element X can undergo the following physical changes. A1. Give the scientific name for each of the numbered physical changes. So you have the first one going from solid to liquid, which is melting. And then the second one, which is going from gaseous element X to liquid. So this is condensation. Liquid to solid, which is freezing. And then going from solid to directly gaseous element X, which would be sublimation. To explain why the changes shown are physical changes, so your answer is supposed to be like how you'd define physical changes and or differentiate it from chemical changes. So there are no new products formed, and also these can all be reversed. One difference between boiling and evaporation is the rate at which the processes occur. State one other difference between boiling and evaporation. So the syllabus mentions how boiling differs from evaporation by the fact that boiling requires heating or it occurs at a fixed temperature. However, evaporation can take place over a range of temperatures. So that's one point you can mention. B. Describe the separation, arrangement, and motion of molecules of element X in the solid state. So there's almost no separation. The molecules are touching each other, or sorry, the particles are touching each other since it's a solid. And their arrangement is regular. And they vibrate in fixed positions. C. Element X is a group 1 metal. It burns in air to form an oxide X2O. Write a chemical equation for this reaction, so you're supposed to be writing it in terms of X. Right, so you have element X reacting with oxygen to form X oxide. And you need to balance out the number of oxygen on both sides, which gives you 4 atoms of element X on the reactant side. 2. Magnesium, calcium, and strontium are group 2 metals. A. Complete the table to show the arrangement of electrons in a calcium atom. So you have the shell numbers, and then you're supposed to be writing the number of electrons in each shell. So the first shell has 2 electrons, as it can hold no more than 2. The second one has 8, continuing within its limits. Third one also has 8, and the fourth one has the remaining 2 electrons. B. Describe how the arrangement of electrons in a strontium atom is one similar to the arrangement of electrons in a calcium atom. Since strontium and calcium atoms are both in the same group, they have the same number of electrons in their outer shell. Two, different from the arrangement of electrons in calcium atom. Right, since calcium and strontium are in different periods, they have different number of shells, and because of that, the outermost electrons in strontium are in the outermost shell, which is the 5th shell, unlike calcium, which has a total of 4 shells. C. Calcium reacts with cold water to form 2 products, a colorless gas, which would be hydrogen, that burns with a lighted, which pops with a lighted splint, a weakly alkaline solution, which is calcium hydroxide, which turns milky when carbon dioxide is bubbled through it. And so one, name the gas P, so it's hydrogen, and this is one of those reactions which you have to memorize. 2, identify the ion responsible for making solution Q alkaline. So solution Q is calcium hydroxide, and hydroxide ion is this ion responsible for the pH. Suggest the solution of solution Q. Right, despite the fact that calcium hydroxide is basic, it doesn't make a solution of too high of a pH because it's not very soluble. Though the pH would be greater than 7, it would not be too alkaline. It should be less than 12 and more than 7. So I'd go with 11. 4, write a chemical equation for the reaction of calcium with cold water. Alright, so you have calcium reacting with cold water to form calcium hydroxide and hydrogen. Alright, so I'd like to mention how this formula of calcium hydroxide forms. You need to know some of the ions, and hydroxide ion is one of them in the syllabus. And so hydroxide ion has a charge of 1, so its valency is 1. You write down the valency or the charge, and since calcium is in group 2, it has a valency of 2, or you can write the charge, which is +2. And then you cross the elements with their valencies. So calcium has only one atom, and there are 2 hydroxide ion in each calcium hydroxide. And now we need to balance the number of hydrogen on both sides, which is 4 on the product side, so it has to be 4 on the reactant side as well, and that's it. The magnesium reacts with chlorine to form magnesium chloride. Magnesium chloride is an ionic compound. 1, complete the diagrams to show the electronic structures of ions in magnesium chloride. Show the changes or on the ions. Okay. So magnesium has 20 electrons, of which it loses 2. So it remains with only 18 electrons, 2 of which are drawn over here. So we need to draw 16 or 8 electrons in each of the 2 shells that have to be drawn. So this one is the last shell. So my orbit is not perfectly circular, but you need to make sure that yours is. And since it has lost 2 electrons, magnesium ion would have a charge of 2+, and each of the 2 chloride ions gains a single electron to fill its outer shell. Alright, I'm not shading over here, but these are the circle ones are supposed to be shaded. They're the chlorine atoms. So this red shell is the one which no longer exists. These red electrons, one of them goes to each of the chlorine atoms to form the chloride ion, and so chlorine would have a charge of -1. Second chlorine ion would have a similar structure with 7 of its own electrons and 1 from the magnesium atom to form a charge of -1. Give 3 physical properties that are typical of ionic compounds such as magnesium chloride, right? And they conduct electricity in molten or aqueous form, since the ions would be separated and they would be able to carry charge. You don't need to write molten and aqueous, you just need to write one to gain one of the 3 marks. Aqueous magnesium chloride is added to aqueous silver nitrate, a white precipitate forms. So that white precipitate would be silver chloride. Write an ionic equation for this reaction. Includes state symbols. Alright, you need to write down an ionic equation that includes the formation of the precipitate, which in this case is silver chloride, right? So I'm going backwards, but you can go forward as well. It's not set in stone. So we start with silver, which has a charge of +1, and then a chloride ion which reacts with silver forms silver chloride. And that's it. 3. Sulfur is an important element. A. Explain how burning fossil fuels containing sulfur leads to the formation of acid rain. So burning any fossil fuels with sulfur impurities gives off sulfur dioxide, which forms sulfur trioxide, which would then get dissolved in water to form acid and eventually acid rain. Now here you don't need to mention all of the steps that occur between the formation of sulfuric acid, since this is only a 2-mark question. Sulfuric acid is made by the contact process. One step in the contact process involves a reversible reaction in which sulfur trioxide is formed. Write a chemical equation for this reversible reaction and include this correct symbol to show that the reaction is reversible. So you start with sulfur dioxide reacts with oxygen to form sulfur trioxide, and this is a reversible reaction. 2. State the conditions and name the catalyst used in this reversible reaction. Alright, so a temperature of around 450 degrees Celsius is used. Pressure of around 1 atmospheres. And catalyst of vanadium oxide. Three. Describe how the sulfur trioxide formed is converted into sulfuric acid in the next steps of the contact process. Alright, sulfur trioxide reacts with sulfuric acid to form the compound oleum, which has the formula H2S2O7, and then that oleum, or the compound made, reacts with water to form sulfuric acid. You don't need to write any of the equations over here since it's not asked in the question. C. Dilute sulfuric acid is used to make salts known as sulfates. A method consisting of 3 steps is used to make zinc sulfate from zinc carbonate. An excess of zinc carbonate, so these are all the steps. An excess of zinc carbonate is added so that all of the acid gets used up, and then a precipitate forms, which would be zinc sulfate, and then you'd separate that by filtering the mixture, and then heat the filtrate to form crystals. 1. Name a suitable piece of apparatus for measuring 20 centimeter cube of dilute sulfuric acid in step 1. So this is a known volume which you need to measure, and so it would be a measuring cylinder that you use over here. 2. State 2 observations which would show that the reaction is complete in step 1. Right, so while the reaction is going on between dilute sulfuric acid and zinc carbonate, zinc sulfate, carbon dioxide are 2 of the products that form. So carbon dioxide is given off in the form of bubbles. As long as the reaction goes on, those bubbles would form, and as soon as the reaction stops, the bubbles would no longer form, or you would no longer be able to see the effervescence. Since zinc carbonate is in excess, that means all of the acid would be used up, but not all of the zinc carbonate or solid zinc carbonate would not be used up. And once the some of the reactant would remain, and once the reaction gets completed, you'd see that no more of the solid, which is zinc carbonate, dissolves. 3. Why is it important to add an excess of zinc carbonate in step 1? Because we don't want any of the acid to remain when during the crystallization process. So we want all of the acid to react and get used up. We don't want any of the acid to remain. We want all of it to get used up with the zinc carbonate. So zinc carbonate has to be in excess. 4. What is meant by the term saturated solution in step 3? So any saturated solution is a solution in which even by further addition of the solute, it does not dissolve at the same temperature. So that's what you're supposed to be mentioning over here, that no more of the solute dissolves in the solution. Or in the solvent. And at the same temperature, which is quite crucial that you mention about the temperature. 5. The equation for the reaction is shown. So you have zinc carbonate reacting with sulfuric acid to form zinc sulfate, which would be the precipitate. So it would be in solid form in water as well as carbon dioxide. And you're supposed to be writing the state symbol. Name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method. So I'm going to be going with zinc hydroxide since it's soluble. 7. Suggest why the method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid. Right, barium is a group 2 metal and their sulfates are insoluble, and that means as soon as the initial barium sulfate forms, not all of the acid would be used up, so some of it would remain, because as barium sulfate forms, it would not form separately as a precipitate like zinc sulfate. Instead, the barium sulfate precipitate, which is insoluble, would form on the surface of zinc carbonate, and that would also prevent the reaction of zinc carbonate with the acid, which would again prevent the reaction from proceeding. So that is the reason barium sulfate is insoluble. D. In a titration, a student added 25 cm cube of 0.2 mole per dm cube aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange to the solution. Dilute sulfuric acid was then added from a beaker to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 centimeters cube. 1. What was the color of methyl orange in the aqueous sodium hydroxide? So methyl orange is yellow in color in any base. 2. Determine the concentration of dilute sulfuric acid in gram per dm cube. So you're supposed to be following these steps. To do that, calculate the number of moles of aqueous sodium hydroxide added to the conical flask. Alright, so looking back at the data given over here, you have the concentration as well as the volume of sodium hydroxide, using which you can calculate the number of moles. Using the formula concentration into volume, you get the moles. But since the volume is given in centimeters cube, I'd suggest that you first convert it to dm cube by dividing it by 1000, and then multiply it with the concentration, which would be, so the answer would be 5 into 10 to the power of -3 moles. To calculate the number of moles of dilute sulfuric acid added from the burette. Alright, so you're only given with the volume of sulfuric acid, which is not enough to find the moles of sulfuric acid, and so you can use the saturation equation and the number of moles of sodium hydroxide. So the equation states that 2 moles of sodium hydroxide react with 1 mole or half of its mole. And that means when you divide this value, which is number of moles of sodium hydroxide, by 2, you get the number of moles of sulfuric acid, which would be the half of it. So that is 2.5 into 10 to the power of -3. Calculate the concentration of dilute sulfuric acid in mole per dm cube. So you have the number of moles and the volume given in the question data. So concentration is the number of moles divided by the volume, 2.5 into 10 to the power of -3 divided by the volume. So you first need to convert the volume which is given in the question into dm cube from centimeter cube. So 20 divided by 1000, which would be 0.02 dm cube, and this gives the answer as 0.125 mole per dm cube. And in the last step, you're required to convert this value from mole per dm cube to gram per dm cube. So all you need to do is convert 0.125 from mole to grams. And the formula of finding the mass from moles is moles multiplied by the molecular mass of the substance, which over here is sulfuric acid. So the molecular mass of sulfuric acid would be 2 into 1. So 1 being the mass of hydrogen, and there are, right, let me write down the formula over here. There are 2 hydrogen atoms in each sulfuric acid in the formula, and then you add the mass of sulfur, and then oxygen, mass of oxygen times 4, because there's 4 oxygen atoms. There are 4 oxygen atoms, which would be 98, and then you multiply this molecular mass with the moles, and that gives the mass, grams per dm cube. Iron sulfate decomposes when heated strongly. 15.2 grams of iron sulfate was heated and formed 4.8 grams of the product. Right, so now here you're given with the names of the molecular mass of the reactant and the product, and you're supposed to be calculating the percentage yield. So percentage yield is concerned with a product, and the main product over here is this compound, since you're given its molecular formula, and you can use the given data, which is the mass of the reactant, to deduce you can use this mass to calculate the number of moles of the reactant, and then use the equation to calculate the supposed amount of moles of the product which should form, and then use that number of moles to calculate its predicted mass. And then you can use the formula actual mass over predicted mass multiplied by the 100. So starting off with calculating the number of moles of the reactants, you need to have mass over molar mass. So starting off with calculating the number of moles of the reactant, so you have mass divided by the molar mass, which is 152, and this gives the answer as 0.1 moles. So you have 0.1 mole of the reactant or iron sulfate decomposing, and as you can see in the equation, 2 moles gives 1 mole of the product that we are concerned with, and that should mean 0.1 divided by 2 should give you the half of its value, which is 0.05 moles of the product. And now you need to calculate its predicted mass. So you multiply the value of moles with its molecular mass, and that would be 8. Using the formula, actual yield divided by the predicted yield and multiplied by 100, you have the percentage yield of this reaction as 60. For a student investigated the progress of the reaction between dilute hydrochloric acid and an excess of large pieces of marble using the apparatus shown. So you have marble chips over here, dilute hydrochloric acid, or also the marbles are in excess. And this gives off carbon dioxide, which would be measured in this gas syringe. A graph of the volume of gas product against time is shown. 1. How does the shape of the graph show that the rate of the reaction decreases as the reaction progressed? So the rate of reaction is shown by the slope of the graph or the gradient of the graph. The steeper the curve, the faster the rate of reaction. So the farther away the curve is, or the less steep it is, the slower the rate of reaction, and therefore the slower the value of the gradient of the curve, so which represents the rate of reaction. We need to use that concept to answer this question. As the reaction progresses, you can see that the distance between the slope and the y-axis increases, meaning the value of gradient decreases and the slope becomes less steep, which means this reaction gets slower. The rate of reaction gets slower. 2. Why did the rate of reaction decrease as the reaction progressed? So this question is regarding rates of reaction, and so you need to bring all of the factors into mind that affect rate of reaction, which include concentration, surface area, and all of that. And as the reaction proceeds, the limiting reagent, which in this case is dilute hydrochloric acid, gets used up, which decreases its concentration, and that affects the rate of reaction. So you need to mention this over here. Three, after how many seconds did the reaction finish? So the reaction finishes when the graph levels off or the gradient is 0, and you can see it gets flat or leveled off around 120 seconds. B. The experiment was repeated using the same mass of smaller pieces of marble. So using smaller pieces increases its surface area, which in turn increases the rate of reaction. All other conditions were kept the same. Draw a graph in the grid to show the progress of the reaction using smaller pieces of marble. Right. So as the rate of reaction increases with surface area, the graph would have a steeper curve or a greater value of gradient, but it would, this is wrong. It would level off with the amount final product being the same, because the amount of product remains the same. The only change is the rate at which it forms. C. The original experiment was repeated at a higher temperature. All other conditions were kept the same. Describe and explain in terms of collisions between particles the effect of using a higher temperature on the time taken for the reaction to finish. Alright, so increasing the temperature, you need to first start with describing how this affects on the time taken. As temperature or kinetic energy is one of the important factors affecting rate of reaction. We know that increasing the temperature means molecules gain energy, they move faster, and as they react faster, the rate of reaction increases, which means the same product would be made in much less time. And so first we need to mention about the time. Less time would be taken to create the same amount of product. and then you need to explain why that is so. So you start out with the rest of the explanation. So reactant particles gain energy, gain kinetic energy, and due to that they move faster. Also, when they move faster, the occasions or the possibilities of their collisions increases, as a result of which the rate of collisions between reactant particles increases, or more collisions occur in a certain time. And finally, increasing the temperature means more number of reactant particles, or a greater proportion of reactant particles have sufficient energy to react, and that sufficient energy is greater than the activation energy. So more particles have energy greater than the activation energy. Five, alkynes are a homologous series of unsaturated hydrocarbons. All members contain a carbon triple bond. Alright, carbon-carbon triple bond. A, complete the table showing information about the first three alkynes. Right, so you have the formulas, and you can make out the formula by looking at its structure. There's like 4 carbon atoms and 6 hydrogen atoms. So that would be the formula in this case. So the second compound in the series, so you have ethine and butane, first, second, and then third, which would be propyne. So Y and E representing the group, and then pro representing the number of carbon atoms, which is 3 over here. B, complete the dot and cross diagram to show the electron arrangement in a molecule of ethine. Show the outer shells only. Right, so as you can see over here, there is a triple bond, meaning each of the carbon shares 6 electrons, or 3 of its own. So I'll be using a cross to represent electrons of a carbon atom, and a circle of the other carbon atom, and then dots for hydrogen. So you have a triple bond, meaning 3 pairs or 6 electrons in total in the covalent bond. Sorry, my circles are a bit out of space over here. And then each of the carbon has a single bond with the hydrogen atoms. This completes the valencies. Compounds in the same homologous series have the same general formula. One, give 2 other characteristics of a member of a homologous series. So you can write any of the 2. Over here, I'll go with the same functional group and general formula. Sorry, I'll go with the functional group and their similar chemical properties. Use the information in the table to deduce the general formula of alkynes. So this series, like alkene, starts with N, or the number of carbon, being 2. So you have, it starts with the number of carbon, or N is 2, and then it increases by 1 every time that you go, as you proceed in the series. So N is going to be 2, 3, 4, and etc. So as you can see over here, the number of carbon is equal to N, so C would be N, and then you have to write the formula of hydrogen atoms in relation to the number of carbon atoms. Looking at the first one, you'd say, oh, hydrogen is also N because 2 is equal to 2, but as you proceed forward, you'd see that it's not the same, the number of hydrogen and carbon is not same in the second or the third compound of the series. So you need to work out a formula that gives the same answer, that gives the right answer for each of the compounds. So here N is 2, N is 3, and here N is 4. You need to somehow carry out an order of operation so that you have the answers as given in the tables. Alright, so just like alkenes, and alcohols, I'd proceed with the initial formula, which is CnH2n, and then in alkenes you add +2, in alkenes you don't add anything, and in alcohols you add +1. See what we have there. So suppose this one, the first one was CnH2n, that would be C2 and H4. But H4 over here is greater than 2. But if you subtract 2, that would give you, if you subtract 2 from 4, that would give you 2. Let's try this on the third compound. You'd have CnH2n. So you have C3 and H6. But if you subtract 2, again you'd have you'd have 4, which is just like the number of hydrogen given in the question. Similarly, in the fourth compound, you'd have CnH2n. You'd have C4, and 2 4s are 8, and if you subtract 2 from 8, you'd get 6. And if you work this out, you'd see that this formula actually does give the right answer. So it would be CnH2n minus 2. The alkynes are unsaturated. Describe a test for unsaturation. So the test is based on double bonds. If a compound is unsaturated, meaning it has double bonds, that means it would react with bromine water when it's added to the compound and change the color of bromine from brown to colorless. E1, name an oxidizing agent which can be used to oxidize ethanol to ethanoic acid. So this agent is acidified potassium manganate, and it's important that you mention acidified because the question has 2 marks, and if you want to gain both of them, you need to write the detail as well. Draw the structure of ethanoic acid, show all of the atoms and all of the bonds. Okay, so first off you have the acid group, and then since it's ethanoic acid, it would have one more carbon atom and then the rest of the hydrogen atoms, filling out its valency. F carboxylic acids can be converted into esters. One, the ester formed by reacting propanoic acid and methanol has the molecular formula C4H8O2. Name this ester and draw its structure. Show all of the atoms and all of the bonds. So while naming ester, you start with the name of the alcohol and then the acid. So the name would be methyl propanoate. And while drawing the ester, you do the opposite. So you draw the acid first and then the alcohol part. You don't need to really draw the reactants, but I find it easier to explain it while drawing the reactants as well. So I'd start with drawing the propanoic acid and methanol first. So you have 3 carbon atoms in propanoic acid, and then its functional group. And then you have methanol. with just one carbon atom in its functional group as well, and then the rest of the valency is filled by hydrogen atoms. So a reaction occurs between the hydroxyl group and the hydrogen atom from acid and hydroxyl group from the alcohol, and this oxygen over here gets left up and a bond forms between this carbon atom and the oxygen atom over here. So it would be the acid group of propanoic acid with the hydrogen atom removed, and then oxygen bonded to a carbon atom, the carbon atom of ethanol. And then the rest of the valencies fill out as well. You draw the remaining carbon atoms. These are all hydrogen atoms, by the way. Name another ester with the molecular formula C4H8O2. So this can be any ester with a total of 4 carbon atoms. So this could be methanol reacting with propanoic acid, and then ethanoic acid reacting with ethanol, and then propanol reacting with methanoic acid. So you have ethyl ethanoate from ethanoic acid and ethanol, and then propyl methanoate from propanol and methanoic acid, as these are the only two combinations that make up 4 carbon atoms in the ester other than the one that we've already drawn. So I'd go with propyl methanoate. G. Polyesters are polymers. 1. What type of polymerization is used in the manufacture of polyesters? This is condensation polymerization, since a water molecule forms as a byproduct. 2. Name a polyester. So the polyester in our syllabus is terylene. Alright, that's it. Thank you for watching.